I'll just say one thing, get ready for what's coming because Missouri is far more surprising and way crazier than you might think. And by the time we get to the final facts, you'll understand exactly what I mean. 50. Border Bonanza. Missouri touches 8 different U.S. states. Iowa to the north, Illinois, Kentucky, and Tennessee to the east, Arkansas to the south, and Kansas, Oklahoma, and Nebraska to the west. That is a lot of neighbors, and it turns Missouri into one of the most connected states in the entire country. Its borders create a natural crossroads where landscapes, dialects, and cultural influences overlap in subtle but fascinating ways. This geographic position also makes Missouri a major transition zone, where the flat plains begin to roll into wooded hills, and where regional identities blend in ways that feel both familiar and unexpectedly unique. 49. That weird little tail, the boot heel. Missouri's boot heel is a distinct geographic oddity, a flat, low-lying extension in the southeast that juts down into Arkansas. Because of its alluvial soils, sediment deposited by the Mississippi River, this part of the state is very fertile and very different in landscape and climate than the hillier Ozarks just to its northwest. 48. Size matters, land versus water. Missouri covers roughly 69,700 square miles in total. Of that, around 68,700 square miles are land, while water covers roughly 965 square miles, or about 1.4%. So yes, you will see lakes and rivers, but most of Missouri is dry land. This balance gives the state a landscape that feels open and expansive, with plenty of room for forests, farmland, rolling hills, and small towns spread widely apart. The relatively small share of water also means that when lakes or reservoirs appear, they tend to stand out as major recreational hubs rather than blending quietly into the background. 47. 4 distinct geographical regions. Missouri is far more than just hills or flatlands. The state is divided into 4 major physiographic regions that each tell a story about its geological past. In the north, the glaciated plains feature gently rolling terrain shaped by ancient glaciers that left behind fertile soils and smooth landscapes. The western plains stretch across central Missouri with a mix of prairies and low hills, offering a transition between north and south. The Ozark Plateau dominates the south with rugged, dissected hills, steep valleys, and exposed limestone and dolomite formations. Finally, the southeastern lowlands, or Boot Heel, consist of flat alluvial plains deposited by the Mississippi River, standing in stark contrast to the rest of the state. These divisions reflect more than just topography. They reveal Missouri's diverse underlying geology, from glacial remnants to ancient igneous and sedimentary rocks, creating a state where dramatic landscape changes occur over surprisingly short distances. 46, yep, it's landlocked. But that's tricky. Missouri is technically landlocked because it does not touch any ocean or sea. However, the situation becomes more interesting when you consider that it is bordered by 2 major navigable rivers, the Missouri River and the Mississippi River. These waterways function almost like aquatic highways, connecting the state to distant regions and major shipping routes. So while you cannot lounge on a saltwater beach in Missouri, barges, commercial vessels, and steady river traffic still move through the area, giving the state access to transportation and trade networks that feel surprisingly coastal for a place without an actual coastline. Before we continue, make sure to subscribe and uncover the hidden stories and curiosities of each U.S. state that no one else will tell you. 45. Northern plains shaped by ancient glaciers. Much of northern Missouri was once influenced by massive glacial activity that reshaped the land long ago. When those glaciers advanced and later retreated, they flattened large stretches of terrain and redistributed huge amounts of sediment. The result is a region defined by gently rolling plains, exceptionally fertile farmland, and the well-known Loess and till soils that form when wind and melting ice leave fine, nutrient-rich particles behind. This glacial legacy explains why northern Missouri has smoother landscapes compared to the hillier regions farther south, and why agriculture thrives so consistently there. 44. Low and slow southeastern lowlands. The southeastern Boot Heel region is part of the Mississippi alluvial plain. It is very flat, very low in elevation compared with the Ozark plateaus, and made up largely of deep alluvial soils created by ancient river deposits. This unique combination makes the area a geographic outlier within the state, almost feeling like it belongs to a different landscape entirely. The land is so level that even small elevation changes become noticeable, and the rich soils have long supported extensive agriculture. Its terrain contrasts sharply with Missouri's hills, bluffs, and uplands, giving the state an unexpected and striking variation in just a few hours' drive. 43. Ozark Plateau dominates the south. If you look at southern Missouri on a map, about half of the state lies within the Ozark Plateau. This is not just a collection of rolling hills. It is a deeply dissected plateau carved by countless streams over time, creating steep valleys, sharp ridges, and rugged, uneven terrain that contrasts strongly with the flatter farmlands up north. The landscape varies constantly as you move through it, shifting from forested slopes to rocky outcrops to narrow hollows. This complexity makes southern Missouri feel almost like a different world from the rest of the state, with elevations rising and dropping in quick succession and giving the region a wild, textured character that stands out in the Midwest. 42. St. Francois Mountains, Missouri's ancient heart. Nestled within the Ozark region, the St. Francois Mountains form Missouri's ancient geologic core, composed primarily of igneous rocks such as granite and rhyolite. Unlike younger mountain ranges formed by recent tectonic activity, these peaks are remnants of some of the oldest exposed rocks in North America, dating back over 1 billion years. Long before the surrounding landscape took its current shape, this area was home to volcanic activity, with lava and magma shaping islands that once rose from shallow ancient seas. Over immense spans of time, erosion stripped away softer sedimentary layers, leaving these rugged, resistant igneous formations as a striking testament to Missouri's deep geological history and providing a dramatic contrast to the rolling hills and valleys surrounding them. 41. Tom Sauk Mountain, sky's the limit. The highest natural point in Missouri is Tom Sauk Mountain, rising to 1,772 feet above sea level. While it may not compete with the tallest peaks worldwide, within Missouri it stands out as a prominent feature of the St. Francois Mountains. The area around the summit is part of Tom Sauk Mountain State Park, offering a network of hiking trails that lead through rugged terrain, lush forests, and rocky outcrops. At the top, a lookout tower provides sweeping views of the surrounding highlands, allowing visitors to appreciate the unique elevation and geology of the region. This mountain showcases how even modest elevations can create dramatic landscapes and recreational opportunities in Missouri. 40. Loess Ground, the St. Francis River. On the opposite end of the elevation spectrum, the lowest point in Missouri is located where the St. Francis River flows out of the southeastern Boot Heel region, sitting at roughly 230 feet above sea level. This stark contrast from the high peaks of the Ozarks, such as Tom Sauk Mountain, to the flat, low-lying alluvial plains illustrates just how geographically diverse Missouri truly is. The river meanders slowly through the fertile Boot Heel, which is composed of rich sediment deposited over thousands of years by the Mississippi River and its tributaries. This lowland area is prone to seasonal flooding, creating wetlands, oxbow lakes, and swamps that support a wide variety of plant and animal life. The drop from the southern highlands to this low point emphasizes how Missouri's terrain shifts dramatically over relatively short distances, from rugged hills to expansive flatlands, highlighting the state's unique and varied landscapes. 39. A rock variety show beneath your feet. Missouri's geological foundation is a fascinating mix of both igneous and sedimentary rock types, giving the state a unique and varied landscape. In the Ozarks and St. Francois Mountains, you'll find ancient granite and other resistant igneous rocks that form rugged hills, steep ridges, and isolated peaks. Across much of the rest of Missouri, the land is underlain by sedimentary rocks such as limestone, sandstone, dolomite, and shale. These layers have been shaped over millions of years, influencing the formation of caves, sinkholes, springs, and fertile soils that support agriculture and forests. The combination of hard igneous cores and softer sedimentary layers creates dramatic contrasts in topography, from flat plains in the north to rolling hills and dissected valleys in the south, making Missouri a geological patchwork with striking variety visible at both the surface and underground levels. 38. Thousands of hidden caves. Missouri proudly carries the nickname the Cave State, and the title is well earned. According to the Missouri Speleological Survey, there are approximately 7,500 to 7,900 documented caves scattered throughout the state. These underground wonders range from small, narrow grottos that can only be explored by crawling to vast, intricate cave systems that have been mapped for hundreds of miles. Many of these caves are found in the Ozarks, where limestone and dolomite bedrock create perfect conditions for underground erosion. Missouri's caves are not just geological curiosities, they also provide habitats for bats, unique invertebrates, and other wildlife. For adventurers and scientists alike, these caves reveal a hidden, subterranean world beneath the rolling hills, offering endless opportunities for exploration, study, and appreciation of the state's remarkable underground geography. 37. Karst topography runs deep. Much of Missouri, especially in the Ozark Plateau, is underlain by karst geology. That means soluble limestone and dolomite are being slowly dissolved by acidic water underground, forming sinkholes, natural bridges, disappearing streams, and, you guessed it, caves. 36. Amazing springs, Greer, Big Spring, and more. Missouri's extensive karst terrain, especially in the Ozark region, creates ideal conditions for some of the most impressive freshwater springs in the country. Greer Spring in Oregon County is the state's second largest spring, releasing an enormous flow of crystal clear water that dramatically increases the volume of the 11-Point River within moments of merging with it. Big Spring, located near the current river, is among the largest springs in the entire Ozark Plateau, producing an astonishing discharge from a towering limestone bluff that makes it look as if an underground river is suddenly bursting into daylight. These springs are not only visually striking, they play a major ecological role. Their cold, steady water supports species that depend on constant temperatures and clean flow, helping maintain river systems even during dry periods. They also shape local landscapes, carving channels, and feeding some of Missouri's most beloved waterways. Visitors often find them to be natural showpieces, where moss-covered rocks, deep blue water, and surrounding forests come together to create scenes that look almost unreal. Together, these springs highlight the hidden complexity beneath Missouri's surface, the vast network of underground passages and aquifers that power these remarkable natural features. 35. Lake of the Ozarks isn't your average lake. Created by damming the Osage River, Lake of the Ozarks has about 54,000 acres of water and, get this, roughly 1,150 miles of shoreline. That's more shoreline than the coast of California, according to some sources. Its serpentine shape weaves through the hills and ridges of central Missouri, making it feel like a vast watery labyrinth. 34. Truman Reservoir is the largest man-made lake in Missouri. While Lake of the Ozarks wins in terms of shoreline complexity, the largest man-made lake by surface area in Missouri is the Harry S. Truman Reservoir. Covering roughly 55,600 acres when at normal pool level, this reservoir extends through multiple counties and feeds a vast recreational zone of coves, wetlands, and wooded shoreline. Its geography is particularly interesting because the lake doesn't fill a single tight valley. Instead, it sprawls out into dozens of wider, low-lying branches shaped by the Osage River basin. The result feels like a hybrid between a reservoir and a floodplain system, creating habitats for migratory birds and offering miles of irregular shore. 33. Mark Twain Lake is surrounded by gently rolling hills. Further northeast, Mark Twain Lake stretches across the Salt River Basin. The terrain around it consists of soft, rolling hills that were lightly shaped by ancient glacial drift. Underlying the region is a mix of shale and limestone that creates solid, erosion-resistant shorelines rather than the dramatic cliffs found in the Ozarks. Because it's less rugged than the southern half of the state, the area around Mark Twain Lake is known for broad views, tall prairie grasses, and gently sloping access to the water. It's a great example of how Missouri's northern topography differs significantly from its southern half. 32. The Missouri River crosses the entire state east to west. The Missouri River enters the state from Nebraska, flows southeast toward Kansas City, arcs eastward, and eventually joins the Mississippi River near St. Louis. This east-west path creates one of Missouri's strongest geographical divides. The river separates the northern glaciated plains from the central and southern uplands. That split is easy to see even from a satellite image. The terrain north of the river looks smoother, while the land to the south is deeply dissected with valleys and ridges. This natural boundary influences everything from soil type to drainage patterns. 31. The Mississippi River shapes the entire eastern border. The Mississippi River flows along Missouri's extensive eastern border, creating a wide floodplain that varies in width depending on the segment of the river. In the northeast, the floodplains are relatively narrow, pressed between the river and rolling hills. But as you travel south, especially toward the Bootheel, the floodplain broadens dramatically into vast flatlands. These low-lying low-lying stretches are influenced by centuries of sediment deposits, giving the area some of the most fertile soils in the state. The Mississippi's scale also generates backwater sloughs, oxbow lakes, and braided channels that define Missouri's aquatic geography. 30. Missouri has a surprising number of islands on the Mississippi River. Islands along the Mississippi River aren't something people often associate with Missouri, yet the state has dozens, some permanent, some temporary, depending on the river's shifting flow. These islands form when sediment carried downstream settles behind natural obstructions, slowly building up above the waterline. Over time, vegetation stabilizes them, creating little land masses that can support trees, wildlife, and occasional sandbars. Many islands change shape or size with seasonal flooding, making the river's geography feel alive. 29. The Ozarks contain hundreds of small, steep valleys known as hollows. A distinctive feature of the Ozark Plateau is its maze of hollows, narrow, steep-sided valleys that can run for miles. They often contain small streams, springs, or seasonal waterfalls. These hollows form because soft limestone and dolomite erode quickly when water seeps through cracks. The result is a dramatic landscape where ridges and valleys sit tightly together, sometimes only a few hundred feet apart. This pattern gives the Ozarks their characteristic rugged look, and the density of these hollows helps explain why roads in the region feel endlessly curvy. 28. Missouri has one of the highest concentrations of freshwater springs in the country. Beyond the famous springs like Big Spring and Greer Spring, Missouri is dotted with smaller but still powerful springs across the Ozarks. These springs form when groundwater, flowing through fractured limestone layers, finds openings large enough to surge to the surface. Because the Ozark region is so deeply cut by valleys, spring water often exits the ground at dramatic overlooks or in secluded coves. Many streams in southern Missouri are fed almost entirely by spring water, giving them clear, turquoise tones and steady year-round temperatures. 27. The Ozark Plateau isn't one plateau, it's several interconnected highlands. People often imagine a plateau as a single flat layer, but the Ozark Plateau actually contains subregions: the Salem Plateau, Springfield Plateau, and the St. Francois Mountains uplift. These areas share broad geological similarities, mostly limestone and dolomite bedrock, but differ in elevation and structure. The Springfield Plateau is gentler and smoother, while the Salem Plateau is more deeply eroded. The St. Francois Mountains are the protruding igneous core. Together, these islands of high ground interlock to form a landscape that is anything but flat. 26. Missouri's sinkholes occur in clusters. Because Missouri has so much karst terrain, sinkholes are common in areas underlain by limestone and dolomite. But these features don't occur randomly. They form in clusters where the underlying rock has the right combination of fractures and water flow. In some counties, you can find hundreds of sinkholes within just a few square miles. Most are bowl-shaped depressions filled with soil and vegetation, but others lie hidden beneath forests or farmland. Their presence shows how active and dynamic the underground landscape is. 25. Tonka State Park contains a rare natural bridge. Missouri has several natural bridges, stone arches created when parts of cave roofs collapse. But one of the most striking is in Tonka State Park. This bridge spans roughly 70 feet and stands above a steep ravine. What makes it geographically interesting is that the rock is the same dolomite found throughout the Ozarks, yet erosion concentrated heavily in this one location. The natural bridge is evidence of just how variable karst processes can be from one hillside to the next. 24. Missouri has a mountain named after an ancient volcano. Prophet Mountain, part of the St. Francois Range, isn't volcanic today, but it's built from volcanic origin rocks. Much of the mountain is composed of rhyolite and other igneous formations created by ancient eruptions and lava flows. Over immense periods of erosion, these hard rocks now stand as isolated peaks surrounded by younger sedimentary layers. The St. Francois Mountains are one of the few places in the central United States where you can stand directly on exposed Precambrian igneous bedrock. 23. Elephant Rocks are giant boulders that reveal Missouri's igneous past. Elephant Rocks State Park features huge rounded granite boulders created when molten rock cooled beneath the Earth's surface and later became exposed through erosion. These formations are called tor structures, large blocks shaped by joints in the rock and long-term weathering. Some of the boulders weigh hundreds of tons, and they sit in clusters along a ridge. Their presence signifies that Missouri's geological roots are far older and more complex than many visitors assume. 22. The Central Missouri uplift creates a subtle arch in the landscape. Central Missouri contains a geological structure known as the Ozark Dome, which creates a gentle uplift across a wide area. Though subtle to the eye, this arch influences the flow of rivers and the distribution of springs. Many streams in central Missouri radiate outward from this uplift, curving around the dome's broad shape. This is one reason the Osage River and Gasconade River follow unusual winding paths rather than flowing in straight lines. 21. The Gasconade River is one of the most crooked rivers in the country. The Gasconade River twists through the northern Ozarks for more than 260 miles. Despite traveling only a fraction of that distance in a straight line, its geography is shaped by the deeply dissected plateau where ridges and valleys force the river to weave around obstacles. This creates long loops, tight bends, and expanses where the river flows back toward its own headwaters before turning again. Because of these meanders, the Gasconade is frequently described as one of the most sinuous rivers in the continental United States. 20. The Black River has 3 distinct forks with different geographies. Missouri's Black River system includes the East Fork, Middle Fork, and West Fork. Each drains different parts of the Ozarks and flows through terrain with unique geological signatures. Some sections cut through igneous rock, producing clear pools with rocky bottoms, while others wind through valleys filled with dolomite and limestone. When the forks merge in Reynolds County, the river becomes a well-defined channel with steep banks and swift currents. The varying geology of the drainage basin creates a wide range of landscapes along its course. 19. Missouri contains prairie remnants in its western counties. Although much of the original tallgrass prairie has been converted to farmland, western Missouri still contains patches of native prairie. These areas sit on loess-covered plains shaped by ancient winds that deposited fine silt across the region. The soil here is deep and rich, supporting grasses that can grow several feet tall. These prairies offer a quiet but striking contrast to the wooded Ozarks, showing another side of Missouri's geography that often gets overlooked. 18. The Loess Hills in northwest Missouri rise like earthen waves. Along the Missouri River in the northwest, towering bluffs of loess, wind-deposited sediment rise sharply above the floodplain. These hills can reach heights of 200 feet and have steep, narrow ridges that resemble frozen waves. Loess is extremely fine and easily carved by rain, giving the hills an intricate pattern of gullies and folds. Missouri shares this landform with neighboring states, but the Missouri side displays some of the most dramatic examples. 17. Ozark streams stay remarkably clear due to their spring sources. Many Ozark rivers and streams remain unusually clear year-round because they are fed by large springs that deliver clean, filtered groundwater. As water travels underground through bedrock layers, it sheds sediment, resulting in streams with a blue-green transparency that feels almost tropical. The steady temperature and flow provided by springs also create stable conditions for aquatic life. This clarity is one of the most visually distinctive geographical features in southern Missouri. 16. Missouri's Ozark Highlands create one of the most ecologically varied regions in the central United States. The Ozark Highlands stretch across southern Missouri, creating a patchwork of forests, plateaus, ridges, hollows, and spring-fed rivers. The variety of elevations and types of bedrock results in a mosaic of habitats, ranging from dry oak woodlands to moist valleys filled with ferns and mosses. Some slopes face south and remain warm and dry, while others face north and trap cool, damp air. These contrasts occur over very short distances, making the region unusually diverse for a state in the central part of the country. The geography of the Ozark Highlands also plays a role in influencing wind patterns and rainfall distribution across the southern region. 15. Crowley's Ridge stands alone like an island on the Boot Heel floodplain. Crowley's Ridge, which runs through the Missouri Boot Heel, rises sharply from the surrounding flatlands. It is composed of loess, fine, wind-blown silt stacked in deep layers that formed hills and bluffs that can reach over 200 feet high. The ridge stands out dramatically because the Boot Heel is otherwise extremely level. One moment you are driving across farmland that seems to stretch forever, and the next you encounter a wooded rise that looks completely out of place compared to everything around it. This contrast makes Crowley's Ridge one of the most visually surprising features in southeast Missouri. 14. The Missouri Boothiel is almost completely flat due to river sediments. Unlike the rest of the state, the Boothiel is a low-lying alluvial plain shaped by deposits from the Mississippi River. Sediment carried downstream for thousands of years settled here in layers, creating extraordinarily level terrain. When viewed on a topographic map, the Boothiel resembles a large pancake compared to the rugged geography of the Ozarks. The soil in this region is very fertile, and its flatness allows water to pool easily, forming wetlands, bayous, and slow-moving drainage channels. Its geography shares more similarities with Arkansas and the lower Mississippi Delta than with central or northern Missouri. 13. Many Missouri rivers maintain a constant flow thanks to springs. The spring-fed nature of streams in southern Missouri means they rarely run dry. Even during low rainfall seasons, groundwater continuously seeps through limestone layers and feeds rivers such as the Current, 11 Point, and Jack's Fork. This steady input supports consistent water levels and prevents the sharp seasonal fluctuations common in non-spring-fed systems. The predictable flow gives the rivers a stable shape, with gravel bars and deep holes arranged in repeating patterns. This geographic stability makes many of Missouri's waterways dependable features of the landscape year after year. 12. The Meramec River has one of the most complex watersheds in Missouri. The Meramec River flows for more than 200 miles through some of the most geologically active parts of the Ozarks. It passes through regions filled with caves, sinkholes, and springs, causing it to pick up tributaries in a seemingly chaotic pattern. The river's watershed contains nearly every type of landform found in the southern half of the state, from rugged hills to soft floodplains. Its valley widens and narrows repeatedly, reflecting the underlying strength or weakness of the rock layers it cuts through. These transitions give the Meramec a landscape that changes frequently as you travel along its course. 11. The White River Hills form one of Missouri's most rugged subregions. In the southeastern Ozarks, near the Arkansas border, lies the White River Hills, a region characterized by deeply cut valleys and steep, narrow ridges. The land is so dissected that straight roads are nearly impossible to build, resulting in winding routes that snake along ridgelines. The hills formed due to the rapid downcutting of the White River system, as it carved through limestone and dolomite. Compared to the more rolling portions of the Ozarks, the White River Hills feel dramatically sharper and more extreme, almost like a miniature mountain range. Before we get to the 10 facts that corroborate what I told you at the beginning, remember to subscribe to the channel and give it a like to become experts in American geography. 10. Missouri's highest densities of caves occur in the south-central region. Most of Missouri's caves are located in the south-central part of the state, where thick layers of limestone and dolomite lie beneath the surface. Rainwater slowly dissolves these rocks, creating underground passages, sinkholes, and cavern systems. Some areas contain dozens of known caves within just a few square miles. The density is so high because the rock layers are both soluble and fractured, allowing water to move easily through them. This underground geography forms networks that can extend for miles and include features like underground streams, domes, and pits. 9. The St. Francois Mountains contain Missouri's oldest exposed rocks. Located in southeastern Missouri, the St. Francois Mountains contain some of the oldest exposed rocks in the central United States. These rocks are primarily igneous formations, including rhyolite and granite, created from ancient volcanic activity. Over an immense amount of time, erosion stripped away younger rock layers, leaving these ancient cores exposed. The mountains rise as isolated peaks, not because they were pushed up recently, but because they resisted erosion better than the sedimentary layers around them. This unique resistance creates a striking contrast between the rugged peaks and the surrounding lower terrain. 8. Johnson's Shut-ins form, where hard igneous rocks constrict a river. Johnson's Shut-in State Park features a section of the East Fork Black River, where erosion-resistant igneous rocks act like funnels. Water is forced into narrow channels, resulting in rapids, pools, and natural chutes. The term shut-ins describes places where a river is confined by rock walls and can't widen its course. The geography is entirely shaped by the durability of the surrounding rocks. Instead of smoothing the landscape over time, the river becomes trapped in these natural stone corridors. It is one of Missouri's most dramatic examples of river geometry determined by bedrock. 7. Missouri's largest natural lake is not a reservoir. While most of Missouri's large water bodies are man-made reservoirs, the largest natural lake is Big Lake in northwest Missouri. It covers roughly 640 acres and sits in a floodplain near the Missouri River River. The lake formed naturally as an oxbow when the river changed course, leaving behind a curved, water-filled depression. Although small compared to reservoirs like Truman Lake, Big Lake is significant because true natural lakes are rare in Missouri. Its shallow depth and gently sloping basin reflect the riverine processes that created it. 6. The Katy Trail follows the long, narrow Missouri River bluffs. The Katy Trail, built on a former railway line, runs for nearly 240 miles along the Missouri River Valley. Much of the trail lies between tall river bluffs and the wide floodplain, illustrating how tightly the bluffs hug the north side of the river in central Missouri. The bluffs are composed primarily of limestone and dolomite that resist erosion, creating a long barrier that forces the river to curve repeatedly. As you follow the trail, the scenery shifts between steep wooded slopes and open lowlands, a direct reflection of the river's interaction with the bedrock. 5. Missouri contains one of the country's few major karst aquifers. Beneath much of southern Missouri lies a vast karst aquifer system, formed in limestone and dolomite layers. Water flows through a complex network of cracks, caves, and underground channels. This aquifer influences surface geography by feeding springs, shaping sinkholes, and maintaining consistent flow in many rivers. Because the water moves quickly through these underground pathways, the system responds rapidly to rainfall, creating interactions between surface and subsurface landscapes that are visible across the Ozarks. 4. The Missouri River Valley creates a wind corridor across the state. The deep valley carved by the Missouri River forms a path of lower elevation that channels air across the state. This corridor influences wind patterns, especially in central Missouri, where winds often follow the river's east-west orientation. The result is a slightly different microclimate compared to the surrounding uplands. The river valley also acts as a heat sink, warming more slowly in spring and cooling more slowly in fall. These effects come directly from the valley's width, depth, and alignment. 3. Glacial deposits in northern Missouri shape the terrain. Northern Missouri's landscape is smoother and more subdued because it was covered by continental ice sheets many thousands of years ago. As the ice retreated, it left behind glacial till, an unsorted mix of clay, sand, gravel, and boulders that leveled and softened the terrain. These deposits created gently rolling hills, thick soils, and a drainage pattern that lacks the dramatic stream-cut valleys found in the southern half of the state. This geological foundation explains why northern Missouri's geography looks calmer and more uniform. 2. Missouri has multiple distinct physiographic regions. Missouri contains several different types of landscapes: the Ozark Plateau, the St. Francois Mountains, the Mississippi Alluvial Plain, Bootheel, the Springfield Plateau, the Salem Plateau, the Northern Plains, and the Missouri River floodplain. Each region has its own landforms, elevations, soils, and drainage patterns. The transitions between them can be sudden, such as when you move from the Bootheel's flatlands into the Ozark's rising hills. These shifts create a patchwork geography that makes Missouri feel much larger and more varied than a single type landscape would suggest. 1. Missouri's geographic diversity is one of the highest in the central United States. From igneous mountains to karst caves, rolling plains, prairies, floodplains, Loess bluffs, and vast river valleys, Missouri contains an unusually diverse range of landforms within its borders. This diversity is the primary reason the state feels so different from one region to another. In the span of a few hours of travel, you can go from flat, fertile farmland to rugged forested hills, then to deep river valleys and high bluffs. Missouri's geography is not defined by one dominant feature, but by the coexistence of many. Missouri is far more geographically complex than most people realize. From ancient igneous peaks to elaborate karst systems, spring-fed rivers, tall Loess bluffs, massive reservoirs, deep valleys, and flat delta-like plains, the state offers an unexpectedly wide range of landscapes. These 50 facts highlight how Missouri's rivers, rocks, hills, soils, and underground systems shape everything visible above the surface. What appears at first glance to be a simple Midwestern state is actually a place where multiple worlds of terrain come together. If anything, Missouri's geography is defined by surprises, contrasts, and hidden details that reveal themselves only when you look a little closer. Now that you know these 50 facts about Missouri, tell us, which one did you like the most, or which one surprised you the most? We'd love to read your opinion in the comments and see how many of us picked the same number. And something else many of us will probably agree on is watching the video I'm leaving on screen, because we all love sharing and learning interesting facts. And that's exactly what this video is all about. But before you watch it, don't forget to subscribe to the channel and give it a like. Otherwise,